So the definition, a matrix is just a rectangular array of mn entries arranged in m rows and n columns. So for example, if I had 3 rows and 2 columns matrix, the number of entries in that matrix is 3 times 2, 6, because they're arranged in a rectangular fashion. That's all this mn means. So most matrices will be designated by a capital letter, and it'll look something like this. It'll be symbolized most generally A11, A12, dot, 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 A1n. Notice it's very, very similar to the arrangement that we had for the linear systems. And of course, there is a way in a subsequent lesson to represent the linear system by a matrix, and we'll see what that is. So A21, excuse me, A22, dot, 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 A2n, and we'll go down, this will be A M1, A M2, dot, 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 A M n. So the top left entry is A11, bottom right entry is A M n. This is an M by n matrix. This M is the rows, sorry. The rows always come first. This is the row, and the N is the column. So M rows, N columns, which is why this first subscript here is an M, and this second subscript here is an N. Okay? Basic example, so something like 1, 5, 6, 7. Oh, a little thing about notation on matrices. You're going to see matrices represented a couple of ways. You're going to see it with these little square brackets. You're going to see it the way that I just did it, which is just 1, 5, 6, 7 with parentheses like that. And sometimes in this particular course, probably not in your book, but in this particular course, oftentimes when I write a matrix, I'll arrange it in a rectangular fashion, and it'll be clear that it's a matrix because we'll be discussing and talking about it as a matrix, but I often will not put the little parentheses around it. Don't let that throw you. There's no law that says a notation has to be this way or that way. These are just conventions. As long as we know what we're talking about, the notation for that is actually kind of irrelevant. Okay. So this is a 2 by 2 matrix. There are 2 rows, 2 columns. You might have something like 3, 4, 7, 0, 6, 8. This is going to be 3 rows, 2 columns. So this is a 3 by 2 matrix. You might have something like this, which is a 1 by 1 matrix. A 1 by 1 matrix is just a number. Which is actually an interesting notion because those of you that go on to study some higher mathematics, perhaps even complex analysis, as it turns out, numbers and matrices share many, many properties. We're actually going to be talking about a fair number of those properties. So the idea of thinking as a number as a 1 by 1 matrix, or the idea of thinking of a square matrix as some kind of a generalized number, it's actually a good way to think about it. So. Not really something that we're going to do, but it's something to think about, maybe in the back of your mind if you're wondering, wow, they seem to behave kind of similarly. Well, there's a reason they behave similarly, because numbers and matrices, their underlying structure, which we're going to examine later on, is actually the same. Okay, so we speak about the ith row and the jth column. So let me do this in blue. We talk about the ith row. We talk about the jth column. So remember the ij, this was the notation. This refers to the row. This refers to the column. So if you have something like A57, we're talking about the entry that's in the 5th row and the 7th column. Just go down 5, go over 7, and that's your entry. Okay. The third. Well, let's actually do a specific example here. Let's say we have a matrix A, which is 1, 2, 3, 4, 7, 9, 10, 4, 6, 5, 9, 6, 0, 0, 1, 8. And they can be negative numbers too. I just happen to have picked all positive numbers here. So we might talk about the third row. That's going to be this thing. So you have 6, 5, 9, 6. We might talk about the second column. The second column is going to be that, 2, 9, 5, 0. Okay. A 1 by n matrix or an m by 1 matrix. These are just single columns or single rows. You can arrange them any way you like. So a 1 by n would be something like this. If I took, let's say, the fourth row, I would have 0, oops, see these lines showing up. We don't want that. Now let's do it over here. So if I take 0, 0, 1, 8, this is 1 by n, in this particular case 1 by 4, or if I take, let's say, 4, 4, 6, 8, this is a 1, 2, 3, 4, 4 by 1. In general, it's not really going to make much of a difference because we are going to give these special names. They're called vectors. And in this particular case, it's called a 4 vector because there are 4 entries in it. You might have a 7 vector, which has 7 entries in it. In general, it really doesn't matter whether you write vectors as columns or rows, as long as there's a degree of consistency when you're doing your mathematical manipulation. Sometimes it's better to write them as columns or rows because it helps to understand what's going on, especially when we talk about matrix multiplication. But in general, both this and this are considered 4 vectors. So, okay. Let's see here. If m equals n. If m equals n. If the number of rows equals the number of columns, we call it a square matrix. Call it a square matrix. So something like A equals, let's say, 3, 4, 7, 10, 11, 14, 8, 1, 0, 5, 6, 7, 7, 6, 5, 0. So this is 4 this way, 4 this way. This is a 4 by 4 matrix. It is a square matrix. These entries, the ones that go from the A11, A22, A33, A44, the ones that have A, I sub j, where I equals j, those entries are called entries on the main diagonal. This is called, do this in red, this is the main diagonal from top left to bottom right. So the entries on the main diagonal of this square matrix are 3, 14, 6, and 0. And again, notice I haven't put the parentheses around them, simply because just my own personal notational taste. So you have a square matrix, you have entries along the main diagonal. Well, a diagonal matrix is one where every entry off of the main diagonal is 0. So something like, if I have A, I have 3, 0, 0, 0, 4, 0, 0, 0, 7. So notice I have entries along the main diagonal, 3, 4, and 7, but every other entry is 0. So this is called a diagonal matrix. A diagonal matrix is a square matrix where only the main diagonal is represented. Good.